Alright guys, so this afternoon what you're going to work through for me is you're going to look at solving exponential equations using logs yeah, and using the exponents as well. So what I want to talk about to start off with is just this idea here. We're going to use our exponents and just manipulate questions before jumping in and playing with some logs. So what we have here is if we have two values that we are told are equal to each other, like a to the power of x is equal to a to the power of y, if we're told that and their bases are the same, because their bases are the same, well, we then assume that their exponents or their powers are also equal to each other. We're going to use that idea that if the base is the same and they're equal to each other, then the exponents are the same, to solve question A and B here. So starting off with just A over on the left hand side here, 27 to the power of x plus 1 is equal to 1 on 81. Well, the idea here is, can we get the bases the same? So while you're writing this example down, and yes, I would like you to write the examples, is there a way you can think of that 27 and 81 can be written as the same base? And hopefully you've thought through it a little bit and you can recognize that 27 is 3 to the power of 3, 27 is just 3 cubed. Well, 81's 9 squared, and because it's 9 squared, that's 3 to the power of 4. So I can rewrite these as 3 to the power of 3, x plus 1 equals 1 on 3 to the power of 4. And looking at the left hand side over here, I'm going to tidy this up a little bit, and I've got my power of a power, so that means 3, the power on the inside, is multiplied by everything on the outside. So I'm just going to skip a line here, that 3 to the power of 3x plus 3 is equal to, on the right hand side there, if I have 1 on 3 to the power of 4, that just becomes 3 to the power of negative 4. And because now I've written the equation with the bases the same, we can then draw the conclusion that, well, 3x plus 3 has to equal to negative 4. And now that we've got that statement down and we can understand that, it's now quite simple to solve for x. We subtract 3 from both sides, so taking 3 away from both sides, we're left with negative 7. And then dividing both sides by 3, we're left with x is just negative 7 over 3. It's one way of solving an exponential equation, is by reducing both sides so that they've got the same base, and using algebra. That is a skill that we can do. Not all questions are like that, and we'll see an example where what to do when we can't, but it's a skill that we can do. We need to be able to manipulate and think of numbers in terms of different bases. Going across to question B here, don't forget, you guys, you can pause the video anytime. We've got here 2 to the power of 2x minus 20 times 2 to the power of x plus 64 equals 0. Cool, I've got two different x's here in two different locations. Don't know. Having a look at this, but looking through this, I'm looking at this and I'm going to just quickly rewrite this differently. I'm going to quickly write that as, well, that's just 2 to the power of x squared minus 20 of 2 to the power of x plus 64 equals 0. And I don't know if you're seeing this, but that's just like, y squared, that's just like minus 20y, and that's just like a plus 64 equals 0. It's a quadratic. All right. By just first of all rewriting that first term, 2 to the power of 2x, as 2 2 to the power of x squared, it kind of looks like a quadratic. So let's do that. Let y equal 2 to the power of x. If we say let y equals 2 to the power of x, we can then write y squared minus 20y plus 64 equals 0. And all of a sudden we've changed something that wasn't looking very nice, looking annoying to deal with, to something that we are quite comfortable in dealing with, and that's a quadratic. We just now need to solve this quadratic. Remember, when we're solving quadratics, looking to factorize first and foremost. If factorizing is not working easily, maybe need to look at completing the square. Don't forget about completing the square. Saw that in our exam with circles, that completing the square is important at times. Or we could jump into using the quadratic formula. I'm looking at this. I'm seeing a positive 64 over here. I'm seeing a negative 20 here. So, this negative here means my highest factor is negative. But because that's positive, both my factors must be negative, because a negative times a negative, equals a positive. Things that multiply to 64, 16 and 4 multiply to 64. So y minus 16 and y minus 4, well, they all equal 0. 16 times 4 is 64, and minus 16 minus 4 is minus 20. Therefore, y is going to equal 16, or y is going to equal 4. Happy days, we've solved the quadratic. Now, let's use this fact that we said let y equal 2x to actually now continue to solve. Well, if 2 to the power of x equals 16, well, 2 to the power of what? 16? Well, 2 to the power of 4. Or 2x equaled 4, so x equals 2, because 2 squared equals 4. And there's our solution to this question. So just quickly going back, 2 questions, both with an unknown, a variable as the exponent that we've been asked to solve. And 2 different ways. We can, on the left-hand side there with question A, reducing everything to the same base. With question B here, kind of recognize we had something that almost looks like a quadratic. And by making a simple substitution, that substitution let y equal 2x, it confirmed, well, it made it a nice quadratic for us to solve, and we used our understanding of quadratics to solve that question. All right, again, remember, pause at any time. If I'm going too fast, pause me. If you get stuck, shoot me a message on Canva.